Each element has a unique atomic number. It's the number of protons in an atom's nucleus. It also tells us the number of electrons orbiting an atom's nucleus. To show how electrons orbit the nucleus, we're using a model. Here, electrons are represented by roller skaters. The orbits occupied by the electrons are circles. The nucleus is the square in the middle. Each atom has the same number of electrons as protons. So if the atomic number is 12, there are 12 protons and 12 electrons. But where are these found? Electrons don't move at random. They circle the nucleus in orbits called shells. Each shell holds a fixed number of electrons. To take a closer look at how these shells are filled, we're going to start with the three simplest elements: hydrogen, helium and lithium. Hydrogen has an atomic number of 1. It has 1 proton and so 1 electron. This single electron goes into the first shell nearest to the nucleus. Next, helium. Its atomic number is 2, so it has 2 electrons. They both go into the first shell. But what about lithium, which has 3 electrons? 2 is the maximum number for the first shell, so the third electron has to go into a second shell. There's a limit to how many electrons each shell can hold. The first shell holds a maximum of 2 electrons. The second shell holds a maximum of 8 electrons. The third shell can also take 8 electrons. Using these rules, can you work out the electronic structure of fluorine, which has 9 electrons, neon with 10 electrons, and sodium with 11? First up, fluorine. 2 of its 9 electrons filled the first shell. The remaining 7 go into the second shell. A shorthand way of writing this is to list the number of electrons in each shell. Next, neon. Its 10 electrons are arranged so that there are 2 in the first shell and 8 in the second shell, which can be written like this. But what about sodium? It has 11 electrons. 2 fill the first shell, the maximum of 8 fill the second shell. And so the remaining 1 electron has to go into the third shell. And this can be written . Comparing an element's position with its electronic structure, there are some interesting patterns. Take group 1. Lithium has 3 electrons. Sodium has 11. Potassium has 19. Compare their outer shells. In each case, they hold just 1 electron. What about group 0? Helium has 2 electrons. Neon has 10. Argon has 18. In this group, the outer shell is always completely full. Apart from group 0, elements in the same group have the same number of outer shell electrons. This gives them similar chemical properties. Each row relates to a particular electron shell. Take the row starting with lithium. Look at the electronic structure. The second electron shell is filled as you go across this row. By the end of the row, this shell is full. Then it's time to fill a new shell, and that means starting a new row. So back to the element we started with. If you remember, it had 12 electrons. What's its electronic structure? And what group does it belong to in the periodic table?